So I'm going to be using Revit 2025. You can download Revit from the Autodesk website. You can use the PCs here in Studio. They all have Revit already pre-downloaded. Or you can use a Porto. So what I'm going to do is I'm going to start a new model in Revit. And I'm going to give you all a template file that I want you to use for this project. So you're not going to be able to follow me along, but you can try. Let me just navigate to it. I will drop it in our canvas, so you all will have access to it. But you're not going to want to open that Revit file. You're going to want to start a new project, and right here where it says template file, instead of choosing their template files here, you're going to browse and search for mine. I suggest you all save that into your folder for this class and keep it organized and have a backup of it. So I'm going to go ahead and click this one here. It's an RTE file, which is a Revit template file. You want to make sure this says create new project. And then I'm going to hit OK. And Revit is going to open up. So one of the first things that you'll see after I clean this text up is just a little welcome dialog box that I've created. And there's a couple of things that you're going to want to keep in mind. Best practices, and then down below, project information. So I would fill this area out by clicking this orange text here. Just single click it once, and then single click it one more time. Give your project a name. Keep it professional. Typically, we give our projects the name of the last name of our client, which in this case could be yourself, could be your friend, could be a family member, and then we just put house, right? So Crowley Residence, or a lot of times what I've seen is architects will just use the first initial of the last name just to be able to show this project off in their portfolio and on their website without having to reveal whose home that is, right? That's sensitive information, right? Their name, their address, the phone number, all those kinds of things. So I'm just going to put the C, we'll just call it C Residence. Okay. And then for client name, I'm just going to put myself. Again, the client might be yourself or a friend or a family member, or it might be a case study, right? And therefore you could just write case study. This is just a study. This is not for anybody in particular. And then go ahead and put your own name in here as well. And by filling out those three areas, it'll automatically populate some of that information onto the title block that I'm having you guys use for my class. Just to give you a preview of what that title block looks like. And I click here on the project browser. Now by default, this project browser might be right here somewhere. Let's see. Oops. Okay, this is probably what your default interface is going to look like in Revit. What I've been trained to do is move the project browser, which is this lower half, click and drag this whole entire panel to the far right, dock it to the right, and you can see as I'm clicking and dragging the name project browser, I'm docking it here to the far right. I'm getting this nice big blue glow, and then once I let go, it'll dock to that side, and then I can also make this a little bit more narrow on this screen. And typically, what I've seen in studios is on the left-hand side is your properties panel, on the right-hand side is your project browser. And by splitting them left and right, you can really get a bigger overview of each one without having to share real estate between the two. So over here in my project browser, if I go ahead and collapse all of these different categories, we can see that we've got views, legends, schedules, sheets, families, groups, and Revit links. BIM software, BIM, stands for Building Information Modeling. So as we're 3D modeling in this program, we're actually adding in quite a lot of information not necessarily just geometry, but this software can calculate square footage, it can calculate volume, you can assign a cost value to specific parts of your assembly of your wall, so that way you know exactly how much square footage of drywall you might use in this project. It's a really smart program. So these are the different categories, and in Revit 2025 and newer, in our project browser, they've added new tabs here at the top, which basically take each one of those categories and gives them that whole entire tab. So either you can have all of those categories listed here on the Home tab, or individually. So here's Views right here. This is Legends. These are all my legends in this project. These are all my schedules in this project, and these are all of my sheets in this project. Sheets are the actual paper title blocks that we're going to be using for this project. We're going to be composing these sheets with our architectural drawings and text and text and annotation, and we will print these out. So the title block that I have for you all is this one right here. It's very simple, minimal, and just has the right information that we need. It is 17 by 11 in proportion. And when I go to print this out, I'll have each of my drawings laid out on each of these sheets. And then I can bind it on the left side or top side and look through this entire project and be able to showcase my project to my client or my partners or friends or family. So this is meant to be bound on the far left side. So all the prime information needs to occur on the far right side, preferably on the far bottom right side. So if you look down here, we've got a bunch of information that is pertinent to this project. Right? If we imagine that we each printed out this entire set of drawings and we all use the same title block, everything is going to look pretty much the same, right? But by me picking up this bottom right corner, I can flip through it and quickly see whose project I'm looking at, what sheet number I'm on, what the project's name is, what semester it came from. And so that's why that occurs on the bottom right corner. C Residence is the project name, so that automatically populates here in the middle. And of course, we've got our Orange Coast College logo. I even found a relic. This is our OCC architecture logo that was designed many years ago. And the big blank spot is obviously where your drawings are going to go. So this sheet, actually these series of sheets, if I go ahead and collapse each one of them, I've given it a simple numbering scheme. A1 is going to be a 3D view. You're going to place your 3D view here, or you're going to place an image, which could be a rendering of your project in 3D, and this will serve as the cover page for our projects. A2 is meant to be the roof plan. Whoops, what is going on here? A2 is meant to be the roof plan. So as you can see, this roof plan is already populated with something, right? And so as we design in Revit, we're going to populate these sheets with these drawings, and this is one of them. This is a simple roof plan drawing, and it's meant to indicate everything related to the roof, including its slope, its materials, where any ridges are, if there's any gutters, and it's really meant to focus solely on the roof properties. The next sheet, floor plan, focuses on your floor plan, right? And when we say floor plan in architecture, we mean doing a horizontal cut through our 3D model, right? Through our home, through our building. And that horizontal cut typically will start at about 4 feet in height. So if we look around this room that we're in the studio, if I were to say, let's cut it at 4 feet, right over there where the door is, there'd just be an air gap, right? There's a side light next to it, so I would see this little pane of glass and the structure on the left and right side of it. I would see the portions of the wall that create the rough opening, and same thing with the other doors and the other side lights in this room. But I would not perceive anything above that 4-foot cut plane, right? I'm simply cutting at 4 feet and looking straight down. That's what a plan or floor plan is. And so as you can see, I've already pre-chosen a lot of graphic styles here for you. So no matter how we create our floor plan, we're going to have this pretty consistent color scheme throughout this our studio here. I've got dimensions, right? Overall dimension strings, some of the minor dimension strings. I've started to number some of my openings, including my doors. This floor plan's not fully developed yet, so I don't have any windows or appliances or enough furniture. But I do have what are called schedules. So these schedules already exist here on this title block. And as you add openings, as you add doors and windows, this will begin to automatically populate with that information. So as we can see here, I've got door number 2 and door number 3. If I go to my door schedule, the schedule lists each one of those doors, gives me information about the width, it gives me information about the height, and if there's a comment that I need to make that might be pertinent to my contractor or the city or my client, I have space to do that as well. Same thing with the window schedule. I have no windows in this project yet, so there are no windows, but if I were to add one, let's go ahead and add one real quick. I'll show you what that looks like. I'm going to double click in this view. I'm going to navigate over to window. I've got looks like I've got one window type. And I'm going to come over here and choose where I want that window. And I'll pop it in there. I'm going to click the little modify cursor so I don't have the window tool available anymore. And if I look at my window schedule, it's already automatically populated window number 1 with a width and a height and then space for a comment. I don't have a label on this window yet, so I can label it if I wanted to. So let's go to this annotate tab, tag by category, and then simply click that window. And now it's got its label on there, window number 1. Typically we'll even give this window a designation with a letter, like a W. You are changing a type parameter. This could affect many elements. Let's not do that, actually. So if I click this window, here's its mark. A mark is the actual nickname or label for that window. So if I change this, it's not going to change this one. And that's because this one is a type mark. I would have to change it right here under type mark. If I change type mark, then it will automatically update there. And if I double click outside of this area and look at my schedule, this is now updated to mark number 2. We'll get more into windows and doors shortly. That was just a quick preview of that. I also have my elevation markers. This is an elevation marker. It's a symbol that shows us where we're looking at the building and which side of the building we're looking at and which way we're facing. So in this elevation symbol, I am looking at this building here from this side, or it could be the south side or the front side of the building. And it also has a drawing number and a sheet number on it. So if I go to sheet A4 and look for drawing number 1, I should see an elevation drawing of this design. So let's go to A4. I'm going to double click that. And there it is. That's exactly what that elevation looks like. I've also got my left elevation on my other sheet, my right elevation on this sheet, and my rear elevation and then my right elevation. each one on its own sheet. Typically, we'll try to compose our sheets in a way where we have multiple views on it at the same time, so we can compare a lot of things all at once, and we can see a window in a floor plan, but we can also see where it lands in our elevation. 17 by 11 is a pretty small set size. Typically we're printing at 22 by 30 or 30 by 40, 36 by 24, 42 by 30, so much larger, so we can fit more information onto each sheet. Let's go back to our little Home tab. Now, a lot of the work that you're going to be doing is going to start here under this specific view that I've named for you, WV Floor Plan. So let's double click that. You can see as I begin to open up new views, I'm getting all of these multiple tabs that start to open. I have a very specific plugin that will colorize all of these tabs. You will not have this colorization, especially if you're using these computers here in Studio. But it allows me to open up several projects, and each project will have its own color, so I can jump between projects fairly quickly. But here's a WV floor plan. Each office has its own standards. From what I've learned, I like to have a drawing that is a working drawing that differs from the actual published drawing that goes on the sheet, and working view is what WV stands for. So in this view, I can do whatever I need to. I can add my walls, I can add new windows and doors and furniture and anything I want, and then hop on over back to the sheet itself with the floor plan on it, and it'll just look correct, right? It's already got all the updated information. It'll have the correct graphics that are consistent with the standards of the office. So if I were to compare the two, let's close each one of these tabs. And if I type in WT allows me to tile my windows. This is the working view floor plan, and then this one on the left is the one that's on the sheet, A3. So if I double click over here in WV floor plan, and I begin to add walls and new doors and whatever I want. Let's put a wall here and a wall there. So you can see it's already beginning to populate in the composed sheet, right? That's because Revit works in such a way where if I'm modeling something in one view, it's constantly updating every single view in the whole entire project. I'm not simply drawing lines in this floor plan view. I'm creating actual wall assemblies. If I were to add a door, I can go to this architecture tab, click door. If I click this drop-down menu here in the properties panel, I'll have different options of doors. I've stripped away a lot of the typical families that you would find here in your templates, just so that way it lightens the weight of this template, so it's very light. You're more than welcome to insert your own families that you would find online or through the Autodesk family library. So if I wanted to add a door and I don't have a door in here yet, I would navigate to the Insert tab, load Autodesk family, and this dialog box will pop up. This is Revit's entire library of what are called families. And in Revit, if you think of a family as an object that you're going to import into your project, that's not necessarily architecture. It's not a wall, it's not a door, well, it could be a door. It could be furniture, it could be a car, it could be a two-dimensional detail. All of that stuff can be downloaded from this dialog box. So we're looking for doors, so I'm going to click doors. Here are the different door styles that I can choose from. Right? Some are meant for commercial projects, some are meant for residential projects, some are very ornate, some are very modern or contemporary, Some are for garages, some are for bedrooms, some are for exterior use, some are for interior use. Some are just some of the components that make up a door. So let's add in, let's say this door here with the full glass panel. I'm going to select it and it'll have this little check mark here, and I'll hit load. Then this dialog box will pop up. Okay. Revit loves to give you dialog boxes, so you're going to constantly be berated with warnings and dialog boxes. It's going to want to ask you tons of different questions. So in this instance, it's going to allow us to download that door family, but it wants us to choose which dimension, which size we want to bring in, right? Because there's all of these already preset choices. And if I were to bring them all in, that would increase the file size. And if I'm not going to even use all 15 of these doors, there's really no point in me bringing them all in. So I'm going to find a door that is 36 inches by 80 inches. 6 foot 8 inches is a pretty typical residential door height and header height. So in typical residential, you see the tops of the doors and the tops of the windows are typically at 6 foot 8 inches or 80 inches. Unless we're talking about 7 foot, 8 foot, 9 foot doors, then those are a little bit different and atypical. So I'm going to bring in a 3 foot by 6 foot 8 door. I'm going to click OK. It's going to take some time to load it in. And then I'm going to go to Architecture. I'm going to go to Door. And there's my door. If I click this drop-down menu, I have my old door that was already here, which is a barn door, and one passage single full light door. So let's grab that one door. I can also, up here in this modified bar, I can click this little button that says Tag on Placement. If I activate Tag on Placement, it'll not only bring that door in, but it'll also tag it immediately. So let's add that door, let's say here. So you can see as I move my cursor around, it'll preview where that door goes. I can move my cursor a bit to the right and the door will change its swing to the other side. If I were to press space bar, it'll flip the orientation of that door swing. So let's put it right here. I'm going to click once, and there's my door, and there's my door tag. I'm going to hit escape 2 times. So in between doing things in Revit, you want to get into the habit of hitting escape, not just once, but twice. And that'll allow Revit to understand that you've ended the previous command. And the second time you hit escape, it makes sure that you've deselected anything that you might have selected. So always hit escape twice in between your commands. So now I've added that door in, and as you can see here on the sheet, that door has been added in as well. The door tag, however, was not added. Okay, so things like annotation, text, dimensions, those kinds of things are only relative to that specific view. So here in the WV floor plan, if I make this view active, type in DI for dimension, or under the Annotate tab, Aligned Dimension, just click that. Now if I make a dimension from here to here, notice how that dimension doesn't show up anywhere in this drawing, right? Things like annotation and dimensions are view specific. Now the actual architecture, the actual 3D model, the refrigerator even, if I were to move that, that will actively move in all views. But things like text and dimensions do not, and door tags as well. So if I wanted to tag this door in this view, the view that I'm actually going to be printing, I would make this view active by clicking in this window. I need to make sure I make this specific view inside of this sheet active by double-clicking it. And then annotate, tag by category, zoom in, select my door, click it once, and now we'll have a door tag. This door tag has what's called a leader. This little line right here is a leader. So it allows me to move this door tag out of the way of a dimension that I might have. And also it allows me to give it an elbow, so that way I can extend it out and to the left. But I'm just going to put it right over here and turn off the leader line, and then just move it right over there. Let's hit escape a couple times. Turn off that leader line again. There we go. All right, so now we've learned that we can work over here in our work view floor plan. We can draw anything we need to. We can move things around, and it will affect the published composed sheet. Okay. If I look at my door schedule, let's close that. Let's look at my door schedule. It's added that number 4 door, 3 foot, 6 foot 8 inches. And as I continue to add more windows and doors to this project, that'll update as well. Let's look at my elevations. I added this door to the left side, or the relative east side of this project. So if I look at sheet A5, drawing number 1, there's my new door. All right. These two are those walls that I had added in the bathroom right here. That's what that looks like. They're coming through the roof. Let's look at this in 3D. I'm going to click this little icon here, default 3D view. And if you don't see your model, go ahead and double click on the middle wheel button, and it should zoom to its full extent. Unless something's hidden here. Oh, there it is. You can also use this view cube, and it'll reorient you. So this is what my project is looking like now. These are the 2 new arbitrary walls that I added. If you hold shift, let's add this thing on, this thing on. If you hold shift and you click and drag the middle wheel button, that's the scroll wheel. If you hold shift, click and drag the middle wheel button, you'll be able to perform what's called an orbit. So you can orbit around your project, see what it's looking like. The reason why these 2 walls are extending past the roof are because their properties indicate that the base of these walls start at level 1, and the top constraint is unconnected. And it really should connect to the underside of this roof. So what I'm going to do is I'm going to attach top base with these 2 walls selected. Let's say attach top or base. Right here in this modify bar, it says attach wall to the top or by its base. I'm going to say by its top. And then it's down here. It says select the roofs, floors, ceilings, topo solid, or parallel walls to which the selected walls should be attached to. I'm going to select this roof. And now it's attached to the bottom side of that roof, and no longer extending so far above beyond the roof. I'm going to hit floor plan and see what that looks like. Still look good in floor plan. I'm going to go to elevation, and now it looks way better in elevation, right? It makes more sense. So with that in mind, what we have here is all of these exterior walls are doing the same exact thing. They're all attaching to the underside of the roof. I mentioned levels, so let's go to our elevations. And as you can see here in elevation, we have a couple of our levels, level 1, 2, and level 3. And each of these levels are spaced out 8 feet. And what these levels allow us to do is have our walls and floors and roofs hosted to those specific levels. So if I were to draw a roof in the level 2 floor plan, it would actually start at that level 2 marker. It would start 8 feet up in the air. Also, I can say, let's make a wall in floor plan. Let's go to my working view floor plan. And let's go to architecture, wall. And right now I'm just using a basic wall, but I have others to choose from. And if I just start drawing some random walls here, I'm going to hit escape to end the command and hit escape one more time to make sure I'm not selecting anything. All of these walls have a base constraint of level 1. They start at level 1 because I drew them in a floor plan that is hosted by level 1. And then their top constraint is unconnected. However, I can tell it to constrain to the very top constraint of level 2 or level 3. So let's look at this in 3D as I affect it in our floor plan drawing. I'm going to close these two tabs. I'm going to type in WT, which is for tiling your tabs, tiling windows. So I'm going to zoom in directly on the floor plan and zoom in here in 3D. And if I select this wall here, and in the properties panel, choose a top constraint of level 2, it will shorten itself to be 8 feet tall, right? Because that's exactly where level 2 starts. If I take this wall over here and say that its base constraint is level 2 and its top constraint is level 3, it will now float in the air 8 feet, and then it will extend 8 feet above that. Okay. If I were to select this wall, I could say start at level 1, but I'm going to give you a base offset, so you start 2 feet above level 1. And then I'll give you a top constraint of level 3, and we'll say I'll give you a negative top offset of -2. Wow, what does that mean, right? So now this wall starts at level 1, but 2 feet up above that. And it ends at level 3, but 2 feet below where level 3 is. So that's how you use those properties and those constraints and your levels. So with that, I'm going to go ahead and get started on drafting this floor plan in front of me. When you receive this template file, you can go ahead and delete all of my work right here. Delete all those walls. Check it in 3D. Make sure you've deleted everything else, such as this roof, this floating wall that's far above that cutting plane, right? I wasn't able to see it in the floor plan drawing, so if I bring that back, Control-Z to undo, right? It's here in the 3D model. Where is it here in this floor plan, right? It doesn't exist in this floor plan. This floor plan is cutting at 4 feet, right, relative to level 1, right? So it's way up here, floating like a ghost, and I'm only looking at this level and looking down. So let's make sure everything is deleted. Don't delete these levels. You want to keep those. But now I'm going to come over here in my working view floor plan. Try to keep your project as centered to this intersection as possible. It'll just work better with the way the drawings are composed on the sheets. And I'm going to start off with my walls. So I'm going to grab the wall command, or the wall tool. On the left-hand side in my properties browser, I have several different types of walls. I want you to think of walls as assemblies. Okay, a wall in Revit means it's layers of vertical siding or vertical substrate composed together to become a wall, right? If we look at the studio around us, there are walls here, right? There is a structural component to these walls. There are waterproofing elements to, probably not these walls, but to our exterior walls. And then there's a finish on either side of the wall. And this wall behind me actually has some concrete masonry unit on the other side and some split face, right? So if I were to think of one of these interior walls as a composition of layers assembled as one wall, it would be drywall, 2x4 stud, and drywall. Okay. So when I come here to choose a wall, I want to be mindful of that. Let's choose exterior wall, wood siding over 2x4, drywall interior. I'm going to click Edit Type. And right here where it says structure, I'm going to click edit. And this shows me the structure of this wall assembly. It is made of wood 19 planks on the exterior side. It's 1/2 inch thick. It is made of softwood lumber. That's 3.5 inches thick. And then on the interior side, it is made up of gypsum wallboard, and that's 5/8 inch thick. So that's the wall assembly. You add all those numbers together, and you get 4 5/8. So that is going to be our wood siding over 2x4. So let's select this wall assembly. And when you get started with your floor plan, I advise that you just simply sketch out a really rough sketch of your floor plan. We can create our walls using various tools such as line or rectangle, polygon, circle. So I'm going to use the line tool. And right here in this modify bar, I'm going to choose core face exterior. So the location line has to do with where I'm referencing that wall in relation to the assembly of that wall. Would I like to reference it by its core, which is the 2x4 stud? Do I want to reference it by the center line of the wall, the center line of the core structure, one face of the core, or exterior or interior? And I'm going to choose core face exterior because we're thinking about the framing first. We're referencing our foundation, and right above our foundation would be our structural wall. And then outside of that structural wall is our finish. So I'm going to choose core face exterior. And this is a very rectilinear plan. So I'm just going to draw from point A to B for my first wall, and then from here to here, here to there, and complete the rectangle. Let's end this command by hitting escape a few times. And the first thing I want to do here is under annotate, aligned, I'm going to dimension all of these walls. So starting with this wall here to here, and then from here to here. And what this allows me to do is understand the proportions of this rectangle that I've drawn. I'm looking at my floor plan. I know that this, let's call it the width of this home, instead of 17 feet should really be 10 feet. So I'm going to select this wall here, and I'm going to zoom into that 17-foot dimension, and I'll select it once, and I'll type in 10 apostrophe. Okay, apostrophe means feet, quotation mark means inches. So I'm going to hit 10 apostrophe, and I'm going to zoom out before I do it, and I'm going to hit enter, and now it becomes 10 feet in width. Okay, so I'm going to hit escape a couple times. So with that in mind, I'm going to select this wall to the far right, select this dimension here, and then I'll type in 32 feet and hit enter. And now my box is conforming to the correct proportions. Let's go ahead and move all of this and try to center it as best as possible to these dashed lines. I'm going to select each one of these walls, holding control as I do it. And we're going to find our move tool, which is this one right here. As you highlight your tools, you'll notice in parentheses there are usually 2-letter keyboard shortcuts. And the keyboard shortcut for this one is MV. So if you were to just type in MV, it would instantly get you the move tool. Okay. Or you can just find that tool here under the modify tab. I'm going to move it. I'm going to click it once. Down below it says to click to enter, move start point. So I want to find a point to which I want to grab it and move it from. So I'm going to grab it by its midpoint right here. So I'm going to zoom in to this 10-foot width. And if I hover my cursor somewhere around the middle, it'll identify the midpoint at 5 feet. Once I identify that midpoint, it'll show me a little red triangle. I'm going to click that little triangle. And I'm going to move it straight down to this reference plane. And then I'm going to do the same thing the other direction. So let's move. Let's find my midpoint, which is, it's right here. And then I'm going to move it to the left to my reference plane. That way it's nice and centered. Let's look at it in 3D. Okay, this is Diana's trailer. It's only 20 feet tall. Okay, so if we had multiple screens to use here, we could tile these two windows so that way we can see our progress here in floor plan view while seeing it update live in 3D. So let's go ahead and split the screen a little bit. I'm going to add, looks like we have one interior wall. Is that right? Just one interior wall on the first floor?
Yes.
Okay. So here in the floor plan view, you can see that this view is active. This view is bold here at the top, whereas 3D is not. Also in my project browser, WV floor plan is bold, right, because it's the active view. If I switch over to the 3D view, notice that now this is bold. And also here under 3D views, that name is bold as well. Back in my floor plan, architecture, wall. Now I need some interior walls. So let's just take the existing wall that I have here. We'll go to edit type and we're going to create a duplicate of this wall. So I'm going to say duplicate and we'll call this one an interior wall. And I'll write drywall. Okay, so she's going to have a very simple drywall kind of window wall. And hit OK. That renaming it doesn't restructure it, doesn't reparameterize the material properties, doesn't change the thickness of it. If I were to call this interior wall drywall 12 inches, it doesn't actually change the width of that wall assembly to 12 inches, right? So it's really just a naming scheme. But if I click edit and come in here and affect the layers of this wall, we're going to take gypsum drywall board and we're going to put it on the top. So if I click where it says wood 19 planks, you'll see this little ellipses pop up. I'm going to click that. And we're going to get to our material library. These are all the materials that come preloaded with Revit. And really, I just need gypsum drywall. So let's find gypsum wallboard right here. Each of these materials has their own graphic properties, which affect the way it shows in our drawings. It also has their own appearance properties, which affect the way that it looks when rendered, as well as physical and thermal properties. Our identity properties allow us to give more information to that specific material. If we were to go to an interiors or finishes manufacturing plant that's showcasing different materials, I can create a brand new material here in Revit, give it that specific name. I can add a couple of different pieces of information that I might know about that material, such as the URL, how much that specific material costs. And all this juicy information is taken into Revit, and we can extract a lot of this information through schedules and reports. That is way above this class. We're not going to do much BIM modeling, but we are just going to model simply. So we're not going to get into that. But I'm going to click OK. I've chosen gypsum wallboard. Click OK. And so now the structure of this wall. Now the structure of this wall is made up of 1/2-inch gypsum wallboard, 3.5 inches of softwood lumber. That's our stud, right? 2x4 studs have a nominal name of 2x4, but an actual measurement of 1.5 inches by 3.5 inches. Okay, so if you go to Home Depot and find a 2x4 and measure it, you'll see it's not actually 2 inches by 4 inches. That's just its nickname. So softwood lumber, I've got it a thickness of 3.5 inches, and then gypsum wallboard again, right? So one side of this wall is drywall, the other side of it is drywall, and then the core structure of it is 2x4. I'm going to change the gypsum wallboard thickness to something consistent between the two. I don't think I would use two different thicknesses unless they're fire rated walls. So now I've got 1/2 inch drywall, 3.5 inch 2x4 wood stud, and 1/2 inch drywall on the other side for a total thickness of 4.5 inches. I'm going to click OK, and I'm going to click OK, and now I have a new wall type, and that wall type is interior drywall. So here my floor plan. Again, I'm not going to precisely place this wall. Instead, I'm just going to find a place for it where I think it kind of goes. Revit got its name because it's the combination of two words, revise and edit. Revit. It's either revise or review. I think it's revise. So what I was trained to do is just simply draw the rough shape of that floor plan, and using dimensions, just kind of muscle it into the shape it's supposed to be. You'll see some instructors will tell you, well, you grab your wall tool, and then you start a wall here, and then you go 32 feet that way, and then you go 10 feet this way, and then you go 32 feet that way. And while that all works, what I've been trained to do is roughly draw it, use dimensions to squeeze it into place, and we'll do the same thing with the interior. So our wall seems to be 10 feet away from the right side. So if I go to annotate, align, I'm going to select this wall here, and I'll select this wall here. When I'm using the dimension tool, I can choose where I'm dimensioning from, and I can dimension from the wall center lines, wall faces, the center of core or face of core, and typically I'm measuring from the face of core. When we're creating these documents, typically we're measuring to structure. So if we have this home on a foundation, that concrete pad or stem walls, the dimensions of that thing pretty much tell us the dimension of the structure of the framing of the walls above it, right? And then any of the finished materials are kind of arbitrary, right? They actually vary in thickness. As far as construction documents go, we're not really concerned about the placement or referencing the finish wall dimensions. We're more concerned about understanding where the structural components of the wall go. So faces of core. And if I were to choose wall center lines, right? When I go to dimension this thing, I can dimension it from center line to center line. If I chose wall faces, I could dimension it from the actual face of the wall, which would be the finished material. Which if you've ever measured a house with drywall in it, and you've tried to get the distance between the two walls in one area and also the distance of those same two walls in a different area, you'll likely get different measurements. And that's because walls are not perfectly straight or perfectly plumb, right? They're actually bumpy. They've got screws that are attaching the drywall to the studs. Then they're patched over with mud, right? So it's not a perfectly flat surface. It's just meant to look like one. So therefore we can't trust those measurements. So I'm going to choose faces of core. I'll measure from this interior face to this interior face. I get 9 foot 2.5 inches. Let's delete these guys. If I select this wall, and right where it says 9 foot 2.5 inches, just click once, and we'll type in 10 feet. Okay, so now that's exactly 10 feet away, measuring from structure. Let's fix the height of this building. How tall is it?
just make it at 13 and a half, tiny house limit.
These, okay. Where does the second level start though?
7 feet, you just say 6.5. Well, that's 6'8", that's what I read.
6'8", yeah, 6'8", okay. So what I'm gonna do is I'm gonna navigate over to my elevation view. Here's the WV working elevation. Let's look at the rear one. I'm gonna close this 3D view. And right here where it says level 2, we'll actually start it at 6 foot 8 inches. So I'm gonna click right here where it says 8 feet, and I'm gonna type in 6'8" quotation mark. And that's gonna bring that level down to 6 foot 8. Let's look at my 3D view again. And I'm gonna select each of these walls. And I'm going to say their top constraint is level 2. So now they're 6 foot 8 tall. That's where my loft is going to start. So let's go to this elevation again, and then what's the floor height on the loft itself? Like where are the top plates?
I haven't gotten to that detail.
Okay. So when we're building our tiny house, in relation to the heights, we're talking about top plate heights, right? There is the mud plate, which is the bottom part of the wall frame. There's all the vertical studs that we're all used to seeing and mounting our TVs to. And then in wood construction, there's double top plates, right? So there's one plate on the very top and then one more right above that. So understanding what the relationship between the mud plate and the double top plate is tells us that floor height, right? So let's just bring our level 3, and we'll just add, I don't know, 8 feet to that maybe, and we'll call it 14.8 for now. So really, these exterior walls should be going all the way to that level 3. So I'm going to change that to level 3. Okay, let's go back to our floor plan, and let's begin to add some doors. So I'm going to go to architecture, I'm going to go to door. I've only got 2 different doors here, a barn door. So we're adding this door. I only have 2 different doors to choose from. So I'm going to bring in another door. I'm going to go to Insert, the Insert tab. I'm going to go to Load Autodesk Family. I'm going to look at all of my doors, and I'm going to pick the correct door. I can select multiple doors and bring them all at once. I suggest you think about these things before you even jump into Revit. I'm noticing here on this set of drawings that there's an idea of exactly how many doors there are, which way they swing. That's all really valuable because then it makes this process a little bit faster. I already have a single full light door. We're going to need probably some sort of pocket door, sure. Okay, yeah. So you're not going to find every door type here in Autodesk's library. And that's one of those instances where you might want to do a little bit of research and find uh, a third party who's already created a family for it. So let's load in this pocket door, single pocket door, load. And let's just bring in a 36 by 80, 3 foot by 6 foot 8. We can always modify these doors to fit our dimensions if we didn't load them all in. For instance, I have a 36 by 80 inch door. If I say edit type and duplicate, give it a new name. Let's call it 30 inches by 80 inches. Again, renaming it doesn't change its dimensions. It just gives it a new nickname. Here under width, I need to change that to 30 inches instead of 3 feet and leave everything else the same. And we'll hit OK. And now I can come in and add my pocket door. And looks like it's somewhere around the middle. So I'm just going to plop it in there and hit escape 2 times to end that door command. And I can click and drag this door and move it around. I can use these flip directions to flip it in the different directions so it actually opens up as the other way. I can flip it left and right, which in this case it's symmetric, so it doesn't really affect it. If it had a door swing, then it would swing inwards or outwards. With this door in place, I can even select it, go to properties, and change it to a barn door if I wanted to. Now it's a barn door. Now, obviously, I need to scooch it so that way it fits inside of the house. And again, I can switch the orientation, left and right, top and front, top and bottom. Let's say we need a special kind of door that's not available to us. Well, we're going to have to search for that. There are a couple really good websites. I will caution you on visiting and downloading these families. They're not always great. Revit has an amazing community of longtime fans. Revit's been around for 20 plus years now. And when someone needs something that Autodesk doesn't have, they'll model it themselves and then give it away for free or for payment. They're not always good. They're not always good quality families. Not to say that Autodesk's families are amazing either. They're not perfect either. They're good starting points, but some of the more premium families that are hyper efficient and super optimized can cost money. So if we go to Revit family, I'm sorry, BIM, let's just Google Revit families. BIM object is one location where you can find a lot of actual products that you might find in stores, including door handles and hardware and fasteners and appliances. BIM Smith Market is another good website. Let's go next. RD Studio has a lot of good Revit families. And I guess the biggest one is probably Revit City. So Revit City, let's go ahead and visit Revit City. It hosts a large library of decades long of different products that models and families that some other users have created and shared. So if we search for accordion door, it is not the fastest website either. But it also allows you to choose a specific year of the Revit file. And as you can see here, it goes all the way back to Revit Building 5, is what the software was called back then. Revit Building 5, and then Revit Architecture with the year on it, Revit Structure, and MEP. So here are some of our choices for accordion doors. Sometimes you'll see someone's shared a specific product that you can buy. Somebody's made some generic accordion style partition. There's a lot of different choices. What you'll see when you're downloading families made from others is most of the world uses metric. And here at the States, we do not. So you'll see some of these dimensions don't fit the mold for our imperial unit of measurement. Also, there could be a language barrier. Some of the actual parameters might be in different languages, right? These are Revit users from all around the world using this website. So let's just try to find the most basic one. Folding partition accordion panel seems okay. Uh, wall system. I want a door though. Okay, I guess we'll try this product here. Some people have created Revit family for the accordion door as a wall, or some of them have done it as doors, like this person has. So you do need to log in. So you need to create an account. They're free. So I'm going to go ahead and log in, and then download now. Okay, here it is. I wouldn't open it. Don't don't try to open that file up. Instead, we're going to say load family. We're going to identify where we put it, which it should be in the downloads folder. And here it is. So we're going to click that. If you were to just open it, it would open the family itself and it would give you the ability to edit this family. You don't have the training to edit this family yet, so we're not going to edit it. Definitely save your projects frequently. I'm going to not save this one for now. And if I go to architecture, go to door, now I have my new door in here. Let's go to edit type and look at some of its parameters. It's 6'10", 173 over 256 of an inch tall by 3'3" and 95 256 of an inch wide. So let's just round that off a little bit. Let's call it 6'8", and let's call it 2'6". Oops, 2'6". And let's just rename it to accordion door. We'll hit OK. We'll hit OK. And then we can add that accordion door in, or I can simply select this door and change it to the new accordion door. And there we go. Let's look at it in 3D. Okay, there it is. It's our accordion door. So let's go back to our floor plan. Let's quickly add a couple more doors. Let's do, we'll just do glass doors for now, and we can swap them out later. We've got a door number 3 is 2'3" or 2'8". Okay, so I'm going to take this door, duplicate it. I'm going to say 2'8", so that's 32 inches by, are you doing 80-inch doors?
Yes.
6'8". So we'll say width is now 32 inches, height is 80 inches, or 6'8". We'll hit OK, and then we'll plop this door in right here. I'm going to click spacebar to flip its orientation, and it goes somewhere over here. Looks like another door over here. Let's flip that orientation. We'll go to edit type. We'll duplicate 2'2". So that would be 26 inches by 80 inches. And we'll say 2'2". Hit OK. And plop that in there. Hit escape a couple times. And I think that's all my drawers. Oh, there's one more drawer that is, oh, is that what the accordion door was?
Yeah, the big side is supposed to be like the outdoor.
Okay. Okay. So it's not this kind of accordion door, actually. It's more like it's kind of a nano wall. So nano wall is a fancy, expensive product. And basically, it's a gigantic opening, and it's made up of multiple panels that can slide or hinge or accordion or both or two different things. They're pricey. The NanoWall is just one of the systems. There's also another affordable one, and I don't remember its name right now. But we can look up that door at another time. So I'll just bring this door over here. So let's do another door, and we'll just put our little dinky accordion door right there for now. And then we'll turn this one into a pocket door. This one right here. And we'll make sure that works kind of. Now let's add, let's see, 1, 2, 3. That's all 4 doors on the first floor. And then we want to do our windows next. So let's go window. There's only one window family in here, but again, you can go to Insert, Load Autodesk Family, navigate over to Window, and pick a window style that you want. There are sliding windows, there are hung windows, single hung, double hung, casement windows, Palladian windows, single and double and triple windows, bay windows. There's a lot of different choices out there in the market, and a lot of them are represented here, but not all of them. Skylights are here as well, so this is where we find skylights. So let's just add, let's just do a fixed window for now. We're going to need to change that at some point. I'm going to go with a 2-foot by 4-foot window for now. And I'm going to change my window size to, what is this window size? Okay, so she's got a giant window on this side. So I'm going to say edit type, duplicate, and let's make it 60 inches wide by 60 inches tall. Because we can afford it today. We've got no budget. So go crazy, guys. All right. Oh, that's dinky. Look at that. That's so tiny. What is that? All right. I'm going to say duplicate again. We're going to go 9 feet wide. So 9 times 12 is 108. So let's say 108 by, we'll still keep it 60 inches tall. I don't think we could do a 108 by 108. Let's hit OK. And the width is now 108 inches. We'll hit OK. Yeah, that's what I was looking for. Oh yeah, heck yeah, that's what we're looking for. So notice how the height of the door, our entry door is 6'8". We want that window to also be at 6'8" to the top, relative to the top, typically. Now, as we saw in our field trip, there were many windows on the tiny house, and they were kind of placed all over the place. So you don't have to go with this flat 6'8" header line all over the place. You can change it up, right? Sometimes we change it depending on where the window is. If it's in the bathroom, we don't usually have a big tall window because we need a little bit more privacy in that place, right? But we'll keep it there for now. We can decide where we really want it in elevation. Right? We can sketch it out and see where it lands, or in section, or in interior elevation. And let's go back to floor plan. Let's put another window over here. So I'm going to go to architecture, window. Let's do another fixed window right here. It's going to be 60 by 60. Let's do another window. We're going to do a small little window over here. Okay, I'm going to place that window. I'm going to select it, edit type, and I'm going to duplicate. And this time we'll go with like a 24-inch by maybe tall.
Yeah.
Okay, so 48. We'll hit OK. Now I need to, so if you already have a window with that same exact name, it's going to tell you about that because you can't have 2 instances of this window with the same exact name. So I'm going to hit close. I'm just going to choose that one, 24 by 48. Make sure the width and height equal that name. Hit OK, and then just scooch it somewhere near the corner. Whoa. Somewhere near the corner. Somewhere near the corner. We got another window in the kitchen, so let's find our window. And let's do another big window right around here. Okay, I think that covers all of the windows. So I've got my doors on the first floor, I've got my windows on the first floor. Here's what it looks like in 3D. As you can see, some of these windows are a little high. So if I select this one right here where it says head height, instead of 8 feet, I'm going to say 6 foot 8 inches. If I want to go with the traditional route, the reason why we keep these header heights at the same level is because it makes it a little bit quicker in construction to knock out the posts that support these headers relatively quickly, especially in wood framing, not necessarily frame CAD, cold form steel kind of framing. But when our contractors are out there, they're looking at the plans, they're cutting every stud to be exactly 8 feet if they're not already 8 feet, and then they're cutting all of their supporting studs to host the header that supports the door that's hung from it or the window that's hung from it. And if they can already understand that all the openings have a head height of 6 foot 8 inches, then they know that they can calculate how many openings there are, multiply that, and figure out how many to cut. So let's bring that down, shift and click to walk around this thing, 6 foot 8. Here's our nano wall door. We'll have to replace that at some point. But I've got a lot of the things that I need for this project on the first floor. Let's navigate to this. Let's actually create a floor. I'm going to click the floor button here. And just like our walls, our floors can have layers as well. If this is our foundation, then it's going to be a one-layered floor, right? Just a bunch of concrete. If it's a concrete slab. So for this floor, I might choose concrete slab 4 inches, edit type, edit the structure, see what it's made out of. Looks like it's made out of 4 inches of concrete cast in place gray. We'll say okay, we'll say okay. And for this one, I'm gonna not draw it by line or rectangle, but I'm gonna pick walls. By clicking on that one, I can come in here and in my floor plan, select each one of these walls. And I've got this little box checked, extend into wall to core, which means that the floor that I'm now creating, its boundaries are the boundaries of where the structural component of the walls are, the 2x4s. So as I move my walls around, if I made this tiny house longer or wider, the floor would move with it because they're hosted by these walls. So let's go ahead and select this wall here. Okay, so I've got all 4 of my walls selected. When I'm talking about layers, I'll show you what I mean. This is a little tool called Thin Lines. I click Thin Lines. What it'll do is it'll take away all the line weights and hierarchy of each of these lines of the drawing and just show me very thin lines for every single component, including our walls. So this is one of our walls. Let's look at it from over here. And this big chunk in the middle is our 3.5 inches of structure, our 2x4. This little part here is the exterior finish. And then this little part here is our interior finish. There's a lot of little tiny thin layers in between that, such as our waterproofing and any of the detail materials for our exterior finish. But essentially, this wall is made up of these 2 finishes and 1 structure. So if I turn off thin lines, all of these line weights come back to make the drawing look clean. I'm going to click this little green check mark, and now I'll have this concrete slab. Let's look at it in 3D, and you can see it down below. We can also see that our finish of our wall hangs off of this concrete just a little bit, right? And that's because the structure of the walls lays directly on top of the edge of the foundation, but the finish does not. The finish just kind of floats there. It's attached to the structure itself. So that's correct. So we've got our first floor. Now we need to draw another floor. So I'm going to go to my floor plans, and I'm going to go to, I need my level 2. So this is right here, WV loft floor plan. That's our level 2. And I'm going to come in here and I'm going to look at my drawing and figure out where my floor is. Got a staircase. Well, is there another staircase here?
Yes.
Oh, got it. Okay, so this is that staircase here? Okay, all right, thank you. All right, so now I need another floor. Right, this floor is going to be above the first floor walls. So let's choose the correct kind of floor. We're not going to put concrete, all right, on our second floor. That floor is not made out of concrete. If we're doing wood framed walls and wood framed roof, we're probably going to do a wood frame floor system, except for the foundation. So we're going to choose, I think this one right here, wood joist 7 inches, wood finish. We'll start there. Let's edit type. Let's go edit structure, and let's take a look at what this thing is made of. If you move this to the side and click preview, it'll give you a small little sectional diagram showing these different layers, right? Just like a cake or a sandwich. It's got one layer on the bottom, another one in the middle, maybe another one and another one and another one and another one, all the way up to your last top bud. So this floor is made up of no finish on the bottom. It's got a 7.5 structure wood joist raft layer, and then a 3/4 finish of wood 05. The names are kind of funny because they actually are, the names of the materials from our rendering software. But essentially, what we have is a 2x8 floor system with a wood floor finish, right? That 2x8 is not actually 2 inches by 8 inches. It's 1.5 by 7.25 of an inch, I believe. I don't know why it says 7.5. So let's look up 2x8 actual 7.25. Right. So 2x8s are not 2 inches by 8 inches. They are 1.5 by 7.25. So back in Revit, I'm going to change this from 7.5 to 7.25. And then my wood finish is whatever, that's based off of whatever finish I actually go out and find at Home Depot or Lowe's or in the junkyards. So I'm going to hit OK. All right, and I'm going to rename this because it's not 7 inches, but I'm going to write 2x8s. Now, how do we know what type of framing we need? Right, we know that our walls are 2x4s. Nowadays, they actually want you to have 2x6 walls. But for a tiny house, that's going to eat up a lot of space, so we'll just keep it at 2x4. 2x6 walls allow us to host more things, such as plumbing and insulation. Right, so to make a better use and be more sustainable, we can have a shell that's thicker and therefore can resist a lot of thermal properties of the exterior and keep the home conditioned without mechanical conditioning. But how do we know if we need 2x8s or 2x10s or 2x12s? So when on our field trip, we learned a little bit about the Roseanne King's tiny house. And one helpful tip she gave us was span tables, right? So as an architect, you can get a pretty general good understanding of what length you can have your framing be based on how much support you might not have under it. And that'll help you dictate how tall those members are, right? So if I were to go out and buy a 2x4 and it was 10 feet long and I had a bunch of them and I started walking on them and they were all 10 feet long, because they're so long and are not supported over those 10 feet, it wouldn't be able to support our weight as we walk around it. So to help with that, we can either add posts below it, so that way they're not cantilevering for 10 feet, but instead maybe they're only floating for 5 feet because we've got posts underneath it in the middle. Or we can fatten up those the framing members to be 2x6s or 2x8s. So our span tables will give us a really good starting point as to what our framing members are, depending on the span that they have to take over. In most residential projects, you're working with a structural engineer, and you are going back and forth deciding how to design this thing properly and under budget. And the structural engineer is the one who controls the structural design of the entire project. So architects give the design and the intentions and the spaces and the finishes and a lot of the city headaches dealing with the permits. And then the engineers just make it feasible, make it logical, right? They put the right structure where it needs to go, and they do a lot of math to do it. So we're just going to go with 2x8s for this. We could probably get away with 2x6s, but we'll hit OK. And now for this floor, let's go architecture, floor. We're going to create this floor. We're going to say pick walls. So I'm going to pick all the walls that it's pretty much attached to, making sure I'm extending into the wall core. And then it also has a big opening somewhere here in the middle. So 7 feet. So I'm going to draw a line somewhere right here. And another one somewhere right here. And another one somewhere right here. And somewhere right here. Okay. So I need to clean these up. I need a closed curve. So I'm going to go and modify. I'm going to say trim. One of these is trim. I'm going to trim each one of these. So for instance, right here, I'm going to select this line and this line to trim it this way. Select this line and that line to trim it that way. Now this one, I'm going to need to slice this horizontal line in half. So I'm going to grab my little slicing tool, which is this one right here, split element. I'm going to split it right here, so that way I can trim it here and here, and also here and here. Okay. And now what I want to do is I want to grab a dimension, and I'll dimension from here to here, and I'll dimension from, what other information do I have? From here to here, and I'll dimension from here to here, and from down here to here, and from down here to here. Escape 2 times, and I'm going to select this line here, and I'll change this dimension to be 7 feet. So 7 apostrophe, enter. This one's 9 feet away from the last one, so 9 feet 9 apostrophe. And then this one here is 1, 2, 3. Looks like 3 feet. And then this one here is going to be 1, 2.5. So we'll call it 2 foot 6 inches. And then this one right here, 1, 2, looks like maybe around 1, 2, 3, 4, 5, 6, 7, maybe 7 feet. We'll have to update that as we enter our stairs. All right, with that, I'm going to hit the check mark. It's going to give me a little warning, a little dialog box. The floor, roof, top solid overlaps the highlighted walls. Do you want to join the geometry and cut the overlapping volume out of the wall? I'm not sure about that yet, so I'm going to say no. Let's go to 3D and check it out. And holding shift, I'm going to click and drag the middle wheel button. And there's my floor. And hit escape 2 times to deselect it. And that's what it's looking like so far. Looks like I've got a couple of walls on either side of this opening. So let's go to our loft floor plan. And let's add those walls. architecture, wall, and we're going to do interior walls. So I'm going to come in here, zoom in to this line here, and I'm going to go this way. Is that right? Do we have walls, like full walls, or?
They're part like triple walls.
Oh, some.
Just to give it
Are they rails or actual walls?
walls.
Walls. Okay, but no wall here.
There'll be railing there.
Okay, so we'll put a wall here. Escape, escape. Do another wall. Oops. From here to here. Escape, escape. Okay, so I've got my two walls. Let's look at it in 3D. They're a little tall. So I'm going to grab both. I'm going to hold Control, click each one. And we want them to start at level 2. And we want them to stop at level 3. So that'll bring that down. And then in here, we're going to have our railing. So let's go back to our floor plan. Let's go to architecture, railing. We're going to draw our railing as a line from point A to point B. We're going to hit the check mark. Let's go back to 3D and check that out. Okay, wow, really simple railing. Just the handrail, it seems. So let's edit this railing. We're going to edit the rail structure. And it has no other structure. Let's insert some structure. Let's move it down. And the height of that structure is going to be, let's see, I don't think I have any defaults. Oh, yeah, I do. Square handrail. Actually, let's hit cancel. Baluster placement is what I was looking for. So regular baluster. We'll do our baluster 3/4 inch. Base is the host. Top is rail 1. And justify off the center. We'll start with our baluster square 3/4. Baluster square 3/4. Baluster square 3/4. And the spacing. Top offset. We'll say every 1'3". Let's hit OK and OK. Okay, you got a basic rail. If you guys need any help with the rail, just call me and I'll come over. So we got that all included. Now this wall is kind of protruding through the floor, so I'm going to select this wall. I'm going to say attach top base, and I'm going to attach it to this floor, and it'll attach it to the underside of the floor. I'm going to hit escape 2 times, and I can still see something else in there, and that's the door. So the door with the full assembly is 6'8". So we're going to need to think about using a shorter door for that area, if this is exactly where our floor is supposed to be. Let's go to our floor plan. That's our first floor plan. This is our second floor plan. And we can add more windows. We can add any doors if needed. Let's add a roof. So I'm going to go to my roof plan, WV roof plan. And the roof looks like a gable roof.
You can make it a shed.
I'm going to show you guys a couple different roof types. So here I am in the roof plan. I click roof. I'm going to click pick walls because I want my roof's overall shape to be based off of the walls themselves that I click right now. And the roof type that I have here are these different ones here. Let's just go with these wood rafter 2x4 asphalt shingles for now. We'll edit type and look at its structure, make sure it seems feasible. 1/4 inch, asphalt shingle, some sheathing, 2x4s, and some. Oh, okay. So this one's got a finish on the bottom side of the roof, which if you have a vaulted ceiling, you would see the underside of this roof, and it's got like wood planks. So I'm going to go ahead and say OK and OK. Now roofs typically will have overhangs called eaves. So I'm going to click Extend to Wall Core, and my overhang is probably going to be modest. So let's go with 6 inches. If you're doing a tiny house on wheels, you're not going to have very large eaves. Like during our field trip to Roseanne's, we saw very small little eaves. So now with the pick walls command, extend to wall core, 6-inch overhang, I'm going to go through and click each one of these 4 walls. Okay, I'm going to click modify or hit escape 2 times. Now, if I left the wall like this, we'll go to 3D. It's going to hit the little check mark, and there it is, right in the middle of the house. Okay, not where we wanted it to be. So, right, it's selected right now, right? It's all blue. So right here where it says base level, you can change it to 3. Okay, and there's the roof. Okay, this is a perfectly flat roof. Okay, which is horrible. Okay, it looks kind of cool, but it's not. And the reason for it is because it has a lot of potential for drainage issues and pooling, right? Water will just collect on this roof, and then the asphalt shingles and the finish and the structure will start to sag and be severed, and water will fall through the drywall or the wood planks that we have and enter into the interior and cause a whole mess of issues. So what we want to do is we want to add a floor. Now I can either edit the footprint of this roof here in 3D or in the roof plan. So let's do it here in the roof plan. I'm going to edit the footprint. And if I want to use a shed roof is when it slopes in just one direction. What I want to do is I want to select any one of these 4 lines. So I'm going to select this one here. And I'm going to click this little button that says Defines Slope. Okay. And while that's selected still, here my Properties panel, under Slope, I can dictate the slope. Slopes are often annotated as a relationship or ratio to the number 12, 12 inches or 12 feet or 12 units. So at this moment, the slope of this roof, the way it says it here in the Properties panel, is basically 612. It's a 612 pitch roof. So if we want to go with a slider pitch, we might just say 312. Oops, 3. Okay. Notice that here it changed to a little triangle that says 312. I hit the check mark, and it's going to bug me to save. Let's go to 3D. Now it has a little bit of a slant. That's called a shed roof. If I wanted to edit the footprint of this roof, select that same wall that I gave it a slope to, and let's give it a 612 slope. I'm going to check. Now it looks like that. So what if we wanted a gable roof, a very traditional roof style? What I would do is I would select both of these lines. Let's look at it in roof plan. Let's select both of these lines. We'll say that they both define the slope and that they're both 512 roof slopes. Check. 3D. Now we have a very typical symmetrical gable roof. Now a hip roof would look like, let's edit this footprint, select all 4 of these lines, make sure that they all define slope, give them all the same slope like 312, hit the check mark, go back here. That's what's called a hipped roof. Each side of it is sloped. Okay. So let's go with, let's not slope those 2. And we'll keep these 2 sloped. What if we do 2 different slopes? Let's take this one and give it a 612 slope. And this one stays as a 312. Oh, where have I seen that before? Okay, so now this roof has 2 slopes. And it's got a ridge, right? This harsh line right there in the middle, that's our ridge. Right? Water falls on it, boop, It either goes left or right, and then it falls to the ground. This is why we want an eave, because if there is no eave, and it just falls, gets into the wall assembly, starts to get behind the finish, starts to separate the finish away from the structure, and now we got to redo all of our walls. Okay, so the bigger the eave, the less of an issue we'll have. And also the goofier it might look. Right, if I select all of these and give it a 2-foot overhang, bam, right? Not really highway safe. And you'll get a lot of birdies, especially if it's a frame CAD. Okay, so here's our asymmetrical roof. I'm going to select this wall, attach top base to here, and I'm going to move around to this one here, attach top base to there. Okay, I've got my window right there. It's so big I can see the second floor. Right, it's like, whoa, look at their feet. Right, there are some things to think about when we do these things, right? We can't just look at it here in floor plan. We have to look at it through elevation. So now let's look at our sheets. 3D view. So if any of these sheets don't have views on them already, you can add your own view. I'm expanding each sheet to show what views are already on it. If I go to my views and I look at my 3D view, I can click and drag that 3D view into the sheet, and it'll ask me where I want to place it. Place it right here. And where is it? Oh, there it is. And it's now that giant on my little sheet. Okay, so maybe we need to think about changing the scale of this. So right now, this 3D view is utilizing an architectural presentation 3D view template. We're not going to go over view templates in this class. Just know that they control all the graphics of your drawings to clean them up, so you don't have to think about that. Let's go for none for now. And for scale, now we can control our scale. Let's change it to 1 inch is equal to a foot, which makes it nice and small. Now I need to figure out where my sheet is, and I'm going to move my view towards my sheet. Okay, still too big. Let's change the scale to 1/4 of an inch is equal to a foot. See if that looks better. And it does. Not great, but it does. So let's go to my 3D view, and holding Shift can kind of reorient it, and that's what it's going to look like. Checking my roof plan. This is what it looks like so far. These little things are the door swings of the doors below them. This is my ridge line, right, to my asymmetrical roof. One's got a 612 roof pitch, the other one's got a 312. Let's look at my floor plan. It's grown since I last had it, so my schedules are no longer fitting properly on it. So if I wanted to, I can select this view, can scooch it over just a little bit by tapping the left arrow, so that way my schedules can fit a little bit better. All of the doors and windows that I've added are here in my schedules. My loft floor plan is here. My front elevation is here. Left elevation is here. Rear, right. All of these are ready to go. I'll go ahead and export this. Oops. Let's do a file, export PDF. Let's select the sheets that we want to print. Let's click this little pencil. And I'm going to use a filter and say, just show me the sheets. I'm going to select all of these sheets. I'm going to hit select. I'm going to browse to find where I want to put this. And let's put it, for now, I'm going to put it on my desktop with the thought that I'll organize it later. Page size, I'm going to use the sheet size itself, which is 17 by 11. And then I'll hit export. It would have been a really good idea to save before I do all this. All right, it's done. I'm going to navigate to where I had saved it. Desktop, Project 1, PDF. Let's maximize this window. Okay, we've got this first one, which we really didn't need. Here's my 3D. Here's my roof plan. Here's my floor plan, elevations. Everything's there. Now with a little bit of cleanup, a little bit more decision making as far as the design goes, we're almost done. Okay. I'll end the recording here and I'll post this online.